Okay, let us discuss this problem again. A rotation about fixed axis. This is a quite interesting problem, you can see. So question number 2. So what the question says, it says uniform rod AB of mass 3m and length 2l. So I have a rod. Let us call this point as A, this point as B. Mass of the rod is 3m and the length is 2l. And is free to turn into a vertical plane about a smooth horizontal axis through A. So there is an axis. So axis is passing through point A. So this means this rod can rotate about this axis in this plane. Now a particle of mass m is attached to rod at B. So there is a particle that is attached, and the mass of this particle is m. When the rod is hanging in equilibrium, it is set into motion with angular velocity kg by l. So now this rod has been given an angular velocity omega. Let us say this rotates in this way, and omega is given to you under root kg by l. So this rod has been given an angular velocity under root kg by l. First part says, if k is equals to 2, find the height of B above the level A when the rod comes to the instantaneous rate. So we have to find height. What is the height that will be reached by the B? Height reached by the B. When it just comes to that this means at that point of time velocity of B just 0. So let us say initially you have something like this. Situation is this, and after some time it is something like this. And then it comes to the rest. Are you getting? So let us try to solve this question. So this is mass of the rod is 3m, length is 2l, and the mass is m. So you find what is the height that is gained. So this height you have to find. What is the height that is gained? Give me the answer in terms of theta. So let us say this angle is theta. So give me the theta. So I will wait for some time. So initial angular velocity is given to you. That is the under root, so omega k is equals to 2, so this means under root 2z by l. So if I put k is equals to 2, omega becomes 2z by l. So now give me the value, what is the maximum height that is reached. Give me the value of theta. So let us wait for some time. Those who have not written the top, let us copy fast. So what you will do, you again have to apply the energy conservation. So first find out the moment of inertia about this axis. Let us check. Let me see how many of your, so this is pure rotation about this axis. If you see the case, this is a pure rotation about the axis passing through A. So this is a case of pure rotation. So this is a case of pure rotation about axis A. Are you getting or not? So if you see, this is a pure rotation about A. Let us first find moment of inertia about A. So for moment of inertia, I have to first find what is the moment of inertia of this rod. About this, I know this becomes ml square by 3 if I have a rod, and the rod, a moment of inertia about 1 it is ml square by 3, mass is 3m, l is 2l, so ml square by 3, this is the moment of inertia of rod. Now plus, I have to add moment of inertia of this mass also. So this is m, and this distance is d square, so this is 2l. So m into 2l whole square. Are you getting? So this, if you calculate, so 3 goes, so you will have 4, 4, 8. So this is at ml square. Let me check how many of you are able to get this one. Okay, if you have done correctly this one, let us find the loss in gain potential energy. If this block is initially here, now it is here. What is the h? So let us say I can say h is nothing but this distance is theta. So this is 2l cos theta. This total distance is 2l. So h is 2l 1 minus cos theta. Are you getting? This distance, total distance is 2l. Now this distance is 2l, so this distance is 2l cos theta. So this distance is 2l minus 2l cos theta. That is, if I take 2l common, it will become 2l 1 minus cos theta. So I can say what is the gain in potential energy? Gain in potential energy is now what are the gain in potential energy we will have? It's slightly a tedious job. You see, for this mass, this is the gain in potential energy, but for this mass, for rod, I can say the center of mass of rod is somewhere here. So this is what is the potential energy gain for the rod. I have to look for the rod. So initially rod was initially from here. This was the height is L. Now what is the height now for the rod? Initially center of mass was here. So there is the L distance from here. Now what is the distance? This distance is you can say L. So this distance is L cos theta. Are you getting or not? So initially it was here. Now this is here. So now gain in L minus L cos theta. Are you getting? So this center of mass of the rod, initially it was above L distance from the bottom. Now it is basically from the top, you can say L cos theta down. So this is L minus L cos theta. I'll leave this one.